Hi guys, welcome to today's lesson. So today we're going to be focusing on compound decay and investments. But just prior to that, we're just gonna go quickly into the revision of what we've done. Just a quick recap of what we've done in our previous lesson. So let's just jump right into it. So remember that our big idea so far is finance, and we've looked at growth. Under growth, we've looked at simple interest, compound interest. Then we looked at the decay, which was straight line and reducing balance. Now we focused on simple interest, straight line. Right now, I want you to just think about this. Have you ever thought about how some people grow their money? So that's our big idea. How do people grow their money? Also, what has been your best choice of saving your money whenever they give you money at home? So remember, growth has to do with simple interest and compound, but we've only so far looked at simple interest. And simple interest, the main thing that mattered there's a time period for earning interest, which was the N. And then remember that you add the same amount to the total at the end of each year. So if they give you interest that is 12% per annum of maybe 1,000 rand, it means you are adding 120 each and every year for the remainder of your investment or your savings. And this is normally shown with this table. So remember, if you saved 8,000 rand, the accumulated amount per year is going to be 120 more each and every year. So the 120 will be a constant value that you're going to add there. So that will be 1,120, 1,240, 1,360, continuing like that. So you see, we are just adding 120 throughout, but I'm sure that you are familiar with this by now. And then now we're going to look at compound interest, which is the main focus of today. So the keywords for compound interest, they include the term or length of time. When we say term and length of time, the reason we don't say number of years or anything like that is because under compound growth, there is what we call compounding periods, right? So with compounding periods, guys, what this means is in a year, you might get interest more than once, though at the end of the year, it will amount to a maybe 12% interest, but getting it on a monthly basis, which means you get 1%, 1% every month. But at the end of the year, it will always be the 12% that they said you're going to get. So that's why we are saying term and not necessarily number of years. Also, our other key word here is principal amount. So you know that this is the amount that you start with when you are investing. I have the accumulated amount or the inflation, which would be the amount that it actually gets to after a certain period of your investment. Then I have my interest rate. The interest rate, remember that it's normally per annum, but it then factors in what we call the compounding period. Remember, the compounding period is all about how often you get your interest. So this will be how often interest is given to you. Now, the equation for compound growth is A is equals to P open bracket 1 plus I all raised to an exponent of A, right? Where our A would then be the accumulated amount, or we can even call this the future value, right? FV, future value. Why? Because it's the amount that you get after a certain period of time, meaning it's the amount you get in the future when you start your investment now. Then the principal amount will be the amount that you start with now when you are starting your investment. So we can also even call this the present value. That's one way we can even look at the principal amount. Then I will be the interest. The interest is normally per annum, but we're going to factor in the compounding period. And then we also have number of times interest is earned. So look at what this says. number of times interest is earned. It is not saying number of years the investment was for. Why? Because in those years, it might happen that in every year you get interest twice, or you get interest 4 times, or you get interest 12 times, or even 365 times. But let's actually see what does that mean. Now we have what we call compounding periods. This is what takes into consideration how often you get your interest. Now let's just quickly talk about this, right? So this means when I say to you your interest is compounded maybe annually or compounded yearly, or which means the same thing, or I say it's compounded monthly, this means that you are getting interest every month or every year. But it does not mean you are getting, if I quoted you 12% per annum and I say compounded monthly, this does not mean that you're getting 12% every month. No. Per annum means the 12% is for the whole year, but it is going to be chucked into bits and pieces that are going to be given to you each and every month, each and every day, each and every week, or every 3 months, or every 6 months. So those are the types of compounding periods we have that we normally deal with. So let's see exactly what it means. So the first one is when it is compounded yearly, right? The two things that get affected because of this are N and I. With N, it means you're getting interest only once every year, hence you multiply it by 1. And then the I, you're gonna divide the interest just on a yearly basis, meaning you divide it by 1. But now, semi-annually, which at times it means half yearly, right? So at times they use the word half yearly, which you also need to be familiar with. It means that in every year, you get the interest twice every 6 months. And then your interest that would have quoted you, you're going to divide it into 2 parts because it is going to be given to you twice in that year. So if I say to you, this is 12% per annum, compounded semi-annually, it means that you are actually getting 6% every 6 months. But at the end of the year, it's supposed to go back to being the 12% per annum. Then quarterly, you look at how many quarters we have in a year. We have 4 quarters, right? And that means you are getting the interest in every year 4 times. And the interest is also divided by 4. So that's what gets affected there, because we're going to divide the 12% that maybe we're still using as an example by 4, which will give us the 4 parts that we're going to give you in a year. The other compounding period, which is commonly used, will be the monthly compounded period, right? This means that you're getting the interest 12 times in a year, and then the interest is divided into 12 parts. So as I said with the previous one, remember we were using 12%, right? Which is normally the same as 0.12. You're going to divide this by 12. Which would then mean that you're getting interest of 0.1% every month. But at the end of the year, 12 times, it must amount to 12%. Then also, if they try to push it, they might also include what we call compounded weekly and compounded daily. So we know that in a year we have 52 weeks, so meaning you're getting the interest 52 times in a year, and then you're getting your interest is divided into 52 bits and pieces that are equal. And also with daily, we know that we normally have 365 days, so you're getting your interest every day. How nice would that be, just to get interest every day? But then we will compare calculations and see whether it would actually make sense to have it maybe on a daily or to have it on a weekly or monthly, like that. Now let's just look at a question that is specific now. It says, David invests 5,000 at 8% per annum compound interest. Now already I know that the 5,000 will be the principal amount or the present value. My 8% will be the I, which is the interest. And then my compound interest will then tell me which growth I am actually dealing with, which is the compound growth. That's what we're still busy with now. What will his money grow to after 5 years if the investment is compounded annually, quarterly, and monthly? Now understand something. If it's 5 years and it's compounded annually, it means that David is going to get interest only 5 times, because it's going to be once each and every year, right? If it's compounded quarterly and it's for 5 years, in each year David will get the interest 4 times, the second year 4 times, so far he has got the interest 8 times. The third year it will be 4 times again, which means that's 12 times. The fourth year it will be 4 times again, and that means it's 16 times. And then the 5th year it will be 4 times, meaning now David has actually accumulated interest that was given to him 20 times in the period of his investment. And then with the last one, which is compounded monthly, it means that every year David gets interest 12 times. For 5 years, that's 60 times. So the number of times that David is going to get interest, if it's compounded monthly, will then be 60. But let's calculate this and see exactly what does it mean. Now for the first one, if we say it's compounded annually, remember you start with writing your data. So I have A is equals to P is equals to I is equals to, and then N is also equals to. My A will be a question mark. That's what I want to know. I want to know what will the amount grow to. And then my P will then be the 5,000. And then my I will actually be the 8% compounded annually. So 8% compounded annually, it means it's just 8%. Then my N will then be 5 years. Then if we substitute this in our formula, 1 plus I to the exponent of n, it will be equals to the 5,000 there into 1 plus 0.08 to the exponent of 5. And then I will just need to use my calculator here. And on the calculator, this is... The calculator. Okay, so if we go to our calculator, this will be 5,000, open the bracket, 1 plus 0.08, all of this raised to an exponent of 5, and this will be 7,346, right? So this will be 7,346 and a number of cents there. Now, if we look at it from a quarterly perspective, remember our A is still a question mark. Our P is the 5,000. Our I now is compounded quarterly, so it means it's going to be 0.08 divided by 4, because remember that we have 4 quarters in a year. Then my N will be the 5 years multiplied by the 4, because you're getting it 4 times each and every year. Then if I substitute this on my formula, it will be A is equals to 5,000, open bracket, 1 plus the 0.08 divided by 4 to the exponent of 20 there. So going back to the calculator again, now I'm just going to change everything here. That's 5,000, 1 plus, now this must be a fraction, 0.08, and it is over 4 raised to an exponent of 20. And that will give me 7,429, right? So this will be 7,429. Let's just go back and see what we got for the first one. for the first one, remember that we got 7,346, right? Now it's 7,429. Just take that into consideration. Let's look at the last one now. The last one is compounded monthly, so that means A is still a question mark, but our P now is still the 5,000. The only thing now that changes will be the I, which means it's going to be 8% compounded monthly. So 8%, it means it's 0.08 divided by 12. And then my N will actually be equals to 5 multiplied by 12. Then on the formula, this is going to be 5,000 into 1 plus 0.08 divided by 12 to the exponent of 60. Then if you go back to the calculator again, I'm just going to change it from here. So this is going to be 60 there. And then my denominator here is going to be 12, because now it's compounded monthly. And then it becomes 7,449. So this is 7,449. So you can see that if it is compounded annually, you still get interest, but it's a little bit less as opposed to if it is quarterly and as opposed to if it is monthly. Now I'm going to show you exactly what does this mean when we come back, because this is mainly what we are going to talk about in terms of the nominal and the effective interest rate. So now you can then think about this to say exactly, is it best for David to invest the money on an annually basis, or on an annually basis interest given to him, or quarterly, or monthly? And then you will then look at that using the calculations. So that's the big idea here. We need to know how often the interest is being given to you, and also whether that will benefit you in the long run. And then again, we look at the duration that you are investing for, because remember that the power of compound interest is in long term and not necessarily in short term. Let's go for a quick ad break, and I'll be back with some more. Stay tuned.